Okay, this is Algebra 2, section 4.8, the remainder and factor theorem, page 287. You guys know long division from elementary. When you took, for example, if I had 48 divided by 5, it would go in there, let's say 9 times 45, and if I subtract, we'd have a remainder of 3, correct? And so if you remember, you wrote this as 9, and then 3/5. You remember that? That was long division, okay? And we did long division with polynomials, remember that? Then we did synthetic division, okay? So we've done all that. But what we're going to talk about today is what we call the remainder theorem. So we're going to concentrate on the remainder of a polynomial, okay? The remainder is what happens when you subtract at the end. You can't take it in there anymore, and it's left out. First of all, the remainder theorem says if a polynomial p of x is divided by x of minus r. So if p of x is divided by x minus r, and it only works for this form, guys, okay? And that's great, because if it only works for this form, then we can use synthetic division, right? Okay? And so if this is true, then the remainder is p of r, which means that I just can put r into the function, and well, the answer I get is the remainder. Now I'm going to show you what that means in a minute. But what the remainder theorem says that the function p of x, sorry, I got r of x up there, I'm not sure why. P of x equals the answer, which we call q of x. The answer is called the quotient, if you remember from elementary. And then times x minus r, that's what we divided by, plus the remainder, which is this. Now, this may look like a bunch of googly-go to you, but the remainder theorem says that whatever you put in and you get back, that is the remainder. All right? So we have two ways of finding the remainder. That we're going to use today. The first way is synthetic division. And we're going to call it synthetic substitution. And the reason it's called substitution because you find the value when you're done. Okay? The second way is called direct substitution. You know both of them. That's the great thing about this. We're not going to learn anything you don't know. Okay? So let me give you an example. If you turn to page 288, example 1, at the top of the page, it says, number 1, if f of x equals 3x to the 4th minus 2x cubed plus 5x plus 2, find f of 4. Okay, now what I'm going to show you, I'm going to do it two different ways. I'm going to do it direct substitution, and I'm going to do a synthetic substitution. Okay? F of 4 means I've put 4 in, so this is direct, and I'm backwards from the book. They did synthetic first, but I'm going to put direct in. F of 4 means I put 4 in for all the x's, so I take 3 times 4 to the 4th minus 2 times 4 cubed plus 5 times 4 plus 2.
Let's have to have one for the missing out of this fourth.
No, I'm not doing synthetic substitution yet. I'm doing direct substitution. So I just put 4 in for all the x's. Remember doing that, Harper?
Yeah.
So I get 4 to the 4th power is what? It's what? 256 times 3 is what? Help me out. I don't have a calculator. 768? Yep. All right. minus 4 cubed is 64 times 2, which I believe is 128, is that right?
Yep.
Plus 20 plus 2. Would you put that in your calculator and tell me what you get? 662, okay? Now I'm gonna do Harper synthetic substitution, all right? So what do I put in the box? 4. I put in 4 because I'm finding f of 4, all right? And so I do 3, a negative 2, and Harper's right, we don't have an x squared, so we're gonna put a 0 in. 5, 2. And I bring down the 3, if you remember, right? 3 times 4 is 12. If I add them together, I get 10. 10 times that is 40. So I get 40 times 4 is 160. 165. What's 165 times 4?
660.
Is it? And then 2 is 662. You'll notice that I got the same thing here as here. Alright, so one is direct and one is synthetic. Okay? So, can we try this? Okay? What I want you to do is try this. I'm going to give you the function f of x equals, here you go, 3x cubed minus 6x squared plus x minus 11. And the number you're going to put in is f of 3. Would you please do it direct and synthetic, please, both? So if we put it in directly, I'm going to put a D for directly, we get 3 times 3 cubed minus 6 times 3 squared plus 3 minus 11, correct? So I get 81 minus
260.
54 plus 3 minus 11. Is that right?
What?
I got 81 here.
54.
Isn't 3 squared is 9? 9 times 6 is 54. What'd you get? 19. So then synthetic, I'm going to put 3 in the box. I have 3 and negative 6, 1 and negative 11. So 3 times 3 is 9. That's 3. 3 times 3 is 9. 9 times 3 is 20, or 9 times, this is 9, sorry, this is 10, sorry. 10 times 3 is 30, and I believe I get 19. Is that correct? All right. Everybody understand it?
So how come, since it was f of 3, right, that you're putting in?
Yep.
So how come it's not a negative 3 that goes into the box?
When they tell you directly what the number is, then you put that exact number in. Great question. If it's a factor, then you change it, because it's got to be in the form x minus r, and they've already done that for you. That's a great question. Okay. All right. So let me ask you something. I'm going to ask you: is x minus 5? Okay. So here's what I'm talking about, Utan. That this is a factor. It's not a number like this one. You see that? Okay, is x minus 5 a factor of x to the third, this is number 3, x to the third minus 7x squared plus 7x plus 15? How do we know if this is a factor of that?
Divide it into it.
You can divide it into it. And what happens if it's a factor? There would be a remainder of 0, correct? So now, Utan, what do we put in the box? Be careful here. 5,
5, right?
yes.
Because
It's the opposite, yeah. Okay, so then it's 1, a negative 7, 7, and 15, correct? Alright, bring down the 1. That's 5. That's a negative 2. Negative 2 times 5 is a negative 10. That's a negative 3. Negative 3 times 5 is a negative 15. Alright, is this a factor?
Yes.
It is a factor. Okay, because we have a remainder of 0. This is called a polynomial factor of this. Alright? And what this has just shown us is what we call the factor theorem. It's another theorem. The remainder theorem said that we can directly substitute in. It's the same as synthetic division. The factor theorem says x minus r is a factor if p of r is 0. In other words, if I put it in, could I have directly substituted it in instead of using, yes, I could have directly substituted in, or I could have used synthetic division. It doesn't matter. If you get 0, it is a factor. Okay? Now, let's talk about this right here. See this right here? Let's talk about that.
Oh, that's it.
What's it called? You guys don't remember? It's called the depressed polynomial.
Did we talk about that?
Yeah, I don't think we ever talked
All
about
right.
that.
Sometimes I get my classes mixed up. It's called a depressed polynomial. See this guy right here? That's the coefficient of the next x term down from this. So it's a coefficient, so it's 1x squared. Okay? And then I just go down. Okay? So this is minus 2x minus 3. That's called the depressed polynomial.
Plus 0.
No, the 0 is a remainder, right?
Right.
So if this is 0, this is called the depressed polynomial. This is the coefficient of the first term that is 1 less degree than the original. And then you just go down. This is the coefficient of the next term, which is 1 down from that. And then this is the constant. You got that? We can also set that equal to 0 and factor it. Actually, we don't have to set it equal to 0. We can just factor it. I believe it is x minus 3 times x plus 1. Is that correct? Is that correct?
Yeah.
What I'm telling you is these two plus x minus 5, this one, let me circle them. These three are factors of this. If I multiply this times this times this, I get this. Do you understand that? That's what it means. These are called the polynomial factors of this. These are called zeros. You know, the 4 over here, these are called zeros because they're the actual numbers. What Uton asked me was, how come this is different? This is a polynomial factor. 5 is the 0. Do you understand? This is a polynomial factor. 3 is a 0. This is a polynomial factor, and negative 1 is the factor, or is the 0, sorry. All right, got it? All right. So let's take a look here on the exercises on page 290. Okay, on 8 through 15, it says use synthetic substitution to find f of 9 and f of 2 of each function. How many answers will you have?
4.
No,
2.
you'll have 2. Let's do number 9, shall we?
Do you mean f of negative 5 and
Oh, what did I say?
f of 9?
I don't know why I said that. Thank you. All right, here's 9. F of x equals x squared minus 8x plus 6. Is that correct? So we're gonna use synthetic division to find, f of a -5. So I'm gonna put a -5 in, oh, you gotta do it over here. I put a -5 over in the box, correct? So I have 1, a -8, and 6, correct? Bring the 1 down, you get a -5, I get -13. -13 times 5 is what? 65? And 6 is 71. So f of a -5 is how much? 71. Now let's do f of 2. Harper, are you okay?
Yeah.
Alright. 1, a -8, 6. Josie, you understand what Joss? Sorry. Sorry, Joss. Did you hear it? You whoops. Alright. So bring the 1 down, sorry. 2, and I get a -6. -6 times that is a -12. And you add 6, you get a -6. So f of 2 is what? -6. Okay. Do we get that? Alright. Let's take a look at 17 through 25, shall we? It says, given a polynomial and one of its factors, find the remaining factors of the polynomial. Okay? I'm going to look at number 23. There's a reason I'm looking at this one. It's kind of a pain in the rear. Trying to decide how I'm going to explain this, but here's the factor, correct? And we want to know if x minus 1, or we want to know the other factors that go into it besides x minus 1. Okay. So what I'm going to do is I'm going to divide, use synthetic division. So what am I going to put in the box? 1. So I go 1, 2, 2, a -2, and a -3. Right? I'm going to bring the 1 down. What should I get in the remainder just before we start? The remainder over here, what should I get? I should get 0. So 1 times 1 is 1. That's 3. 3 times that is 3. I get 5. 5 times that, I get 3. 3 times that is 3, and I do get 0, correct? So the depressed polynomial is what? X to the third plus 5x plus, alright. Nope. This is the problem. You'll notice that we're going to do the odds, by the way. 17, 19, 21, 23, and 25. We're going to do the odds. But you will notice that all of them, except for 23, all are x cubed. So your depressed polynomials are all going to be quadratic functions in which you can reverse FOIL. This one you cannot reverse FOIL. That's why I'm doing it in class. So what I'm going to do is I'm going to tell you that if x minus 1 is a factor, oftentimes x plus 1 is a factor. Why?
Because
Difference of squares. Okay? So let's see if a -1, because this one's a -1, let's see if -1 goes into this one. Okay? So we have 1, 3, 5, and 3, correct? I'm doing it into this one. You understand it? So now I bring down the 1. 1 times -1 is -1. That's 2. 2 times -1 is -2. That's 3. And 3 times -1 is... So look at that. All right. So my depressed polynomial is? That's right. You cannot factor this anymore. It won't reverse FOIL without using the quadratic formula. So therefore, it is your last one. So there are your 3. 1, 2, 3. I'm going to state this again, Greeley. On the other ones, 17, 19, 21, and 25, you'll have quadratic equations, which means they're x squared, and you can reverse FOIL them. Does that make sense? Alright, I will, what time is it already?
54.
Okay, I will talk about 16 for just a minute. Why? Because it has words in it. For some of you that are allergic. What's that?
Are we doing odds?
We will at 17 through 25. Sorry. Did that hurt your feelings?
You did.
Yeah, along with the old cupcake kind. Alright. Alright, it says, a specific car's fuel economy in miles per gallon can be approximated by f of x equals that number, that column there. That thing's crazy. Where x represents the car's speed in miles per hour. Determine the fuel economy when the car is traveling at 40, 50, 60 miles an hour. Okay? Let's just do 40. Okay? So you don't have to do 50 and 60. Alright, how would you do 40?
Put all those
Put
numbers,
40 in a box.
Yeah,
And then
put all those numbers in a line, or
Yeah.
and then do synthetic substitution.
or you could directly substitute it in.
Yeah.
Either
that'd
one.
be easier.
What's that?
I said that might be easier.
I think 40 indirectly substitute in, and you gotta plug it into your calculator, okay? And it'll pop it out for you, but it'll be nasty, okay? So we're just gonna do 40. Would you tell the wrestlers we're just gonna do 40?
Yeah.
Okay, so your assignment for Tuesday,
Chelsea, go write it, but make sure you write it down.
page 290, numbers 8 through 16, comma, 17 through 25 odd. It's due Tuesday. Please work on it at least to the end of the period so that you got a little bit of it, a little bit of knowledge in your head about it, because I don't want to redo this. Now, if you ask me how to do it on Monday, I'm going to say watch the video. Okay? All right? Harper. I'm going to shave that head one of these days. Hey, we better stop this before I get in trouble. Yeah.
So what would happen if you did like try to do synthetic division on something that had like two like x squared terms or something like that?
You can't use synthetic division. That's the problem.
Okay.
Yeah.
So you just can't do it for those
Yeah.
ones.